Hi everyone, welcome back to my number sense series. Today we're going to continue our fraction and decimal conversion series, but this time we are going to generalize. We are going to talk about every repeating decimal and how to convert it to a fraction. Starting with the most basic, things like 0.3 repeating. Now if you remember our first video on decimal and fraction conversion, you should be able to recognize that this is 1 over 3 or 3 over 9. But how can we get from the decimal form to the fraction? We know how to get from the fraction to the decimal, but what if you didn't know that this is 1 over 3? How could you prove that it's 1 over 3? Well, here is the process. First, let x be equal to 0.333 all the way to infinity, right? Now, infinite things are tricky. So our motivation is that we want to get rid of the infinite things. And how can we get rid of the infinite thing? Well, we might want to subtract one infinite thing from another infinite thing. If we do it in the right way, they'll all cancel out and it'll be zeros until the end, and we can get like an integer out of it. So the process that we do here is 10x. 10x, we simply move the decimal point 1 to the right, and we get 3.333. And this is exactly what we want, because if we subtract these two, you'll now notice that these will cancel out exactly. All these infinite 3's after the decimal place will become zeros, and we'll be left with just a whole number. If we subtract this from this, we'll get 9x equals 3. Very simple. And thus x equals 3 over 9, or 1/3. So this is like the very basic process of turning an infinite decimal into a fraction. And of course, it gets more complicated than this, but it is still fundamentally the same process. For example, 0.13 repeating. How can we do this? Well, if we multiply it by just 10 this time, right, we'll get 1.313, but that doesn't actually line up. We want 1313, not 3131. So we need to multiply it by 100. If we let x equal this, then a 100x will equal 13.1313, and now we see that this again lines up very nicely, and we'll get, if we subtract these two, 99x equals 13. And so x equals 13 over 99. And you might start to notice a pattern here, but let's just continue and do one more example. 0.451. Once again, we're going to do the same process. We want a 0.451451 that we can cancel out. And how are we going to do that? Well, this time we're going to multiply it by 1,000. And we have 1,000x equals 451.451451. And then if we subtract these two, we'll have 999x equals 451. So x equals 451 over 999. And once again, let's check if this can be simplified. Recall that 999 equals 27 times 37. So we need to test this for divisibility by 3. It's not divisible by 3, and it's not divisible by 37. So we know this is going to be our final form. And for this as well. And so after these 3 examples, if you look a little bit, you should be able to see a pattern. And what is that pattern? Well, if we have a pattern of n repeating digits, and the digits are, some number, for example, here it's 13, then the decimal form, or the fraction form, is going to be that number over a number which is made out of as many 9s as you have repeating digits. So for example, here we have 13 and we have 2 repeating digits, so it's 13 over 99 because we repeat twice. Here we have 451, and 4, 5, and 1 are repeating, so we have 3 repeating digits, so it's 451 over 999. Hopefully that makes sense. And it should also make sense mathematically, because every time we add one repeating digit, we have to increase the power of 10 that we multiply by multiplying it by 10. So here we have 99x, here we have 999x, because we have 100 and 1,000 from the 2 repeating and the 3 repeating respectively. Hopefully that makes sense. And so this is a generalization of every repeating decimal, right? 0.33 here, instead of looking at it as 3 repeating, we could look at it as 3 repeating, and we would get 33 over 99, which is again 1/3, so the same idea. So let's do some practice. What is 0.4242 da 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 da? When you see this ellipses, this dot dot dot, you can assume that it's like a repeating pattern. So 4242 is equal to just 0.42 0.42 with a bar over it. And what is this? If we look back at here, we'll see something very similar, and we'll be able to say that it's 42 over 99. But wait, don't write this as your answer in contest because it will be counted wrong, because as you should note, this can be simplified. How can it be simplified? Well, 99 is 9 times 11. So we should be on the lookout for a multiple of 3 or a multiple of 11 up here. And 42 is a multiple of 3. And so it actually simplifies to 14 over 33. This is what you would write in contest. Now, 0.123 repeating. Again, if you look up here, it's a very, very similar idea. 0.123 repeating, what is that going to be? Well, it's going to be 123 over 999. Once again, because we have 3 repeating digits. But once again, this can also be simplified. Recall that 999 is made up of 3's and 37. 123 is 3 times 41, so we should factor out that 3. And so we're going to get 41 over 333 for this. And before we end off the video, I want to leave you with one more note. What is 1 over 7? As we covered in our last video, 1 over 7 equals 0.142857 repeating. But using this new logic, 0.142857 repeating should be equal to 142857 over 9999999, which means that this equals 1 over 7, which also means that 7 times 142857 must equal 999999, and that is a beautiful fact. Also, hopefully, one that you remember that we covered. So this is a very, very intriguing connection. So hopefully that makes sense for converting repeating decimals to fractions. In the next video, we will cover different cases, like what if you don't have 0.33, but instead you have 0.133333. That is a different case that we're going to have to consider in a different perspective. But if you understand this, you're going to be very, very well set up. And also, it's just really cool to know. So thank you guys for watching, and I'll see you next time.